morning, good afternoon, good evening, wherever you are. Before I just go ahead, I just want to appreciate Ifeanyi, the NAPE-YP lead, and the entire executive of NAPE-YP for inviting me to give this talk today. My name is Promise, and I'll be presenting the challenges of applying AI in the energy industry, the problems, the challenges, possible mitigations, and the opportunities for YP in those challenges. But before I go into all of that, let me just give a brief background to myself. I have a BSc in geology from the Federal University of Petroleum Resources. In 2016, I then joined DigiConnect as a geoscientist, where I was involved in seismic interpretation, petrophysical evaluation, and just trying to help make investment decisions. From DigiConnect, I went to Imperial College, London, to study petroleum geosciences, and this was where I began my data science journey. I did my final thesis in machine learning, using machine learning to predict lithologies from well logs, and I gave that talk about some weeks ago at the NAPE UK Europe chapter. And currently, I am a data geoscientist with CGG, where I'm applying my data science skills and geoscience skills to help solve subsurface and energy-related problems. I recently started out a channel focused on equipping professionals, people interested in data science, artificial intelligence, and machine learning, applying this within the industries. So I've dropped a few videos. If you're interested in talks like this, you could check out my YouTube channel. So for this presentation, I'll be taking you through an overview to artificial intelligence, data sciences, machine learning. I will talk about specific applications of AI in the energy industry, what companies are doing, talk about the challenges and the possible mitigations to these challenges. I feel like this conversation is, rather than being a presentation, it should be a conversation. So I'll try to keep my presentation short so that we have enough time to discuss these challenges, because they are real challenges that we are being faced in the industry today. So I feel like at the end of the session, we should have brainstorming sessions to see how we can mitigate these challenges, because whatever I'm going to talk today will be based on my experience. I know that we have lots of experienced professionals here, so they'll be able to also share their problems, and we come up with unique solutions that will be impactful in our energy industry. So what is data sciences? What is artificial intelligence? I'll just say, I like giving this analogy. If you have listened to my talk before, you'll be familiar with this diagram. Artificial intelligence is trying to make your machines act like humans, trying to make machines make intelligent decisions in the same logical manner a human will approach this. And there are different types of artificial intelligence. A subset of artificial intelligence is machine learning, where you train your machines to do things without being programmed to do so. A normal programming, a programmer would give the computer a function such that when you give it any variable, it gets your outcome in form of Y. So for example, a programmer would specify to a machine, for example, my function is X to the power 2. So anything I give my computer X, it just multiplies that by itself to give it your Y. So if I give it 2, for example, it outputs it as 4. If I give it 6, it outputs it as 36. But for machine learning, you don't program anything. You just give the machine your data. Where you have labels, you give. If you don't have, you don't give. The machine then looks at the data, looks for trends and patterns, and come up with unique algorithm or function that captures all the important things within the data, such that when it outputs that function in form of model, subsequently you can feed your problems into the computer, and it uses that function it has created and learned by itself to get your unique solutions. There are 3 different types of machine learning. We have supervised machine learning, where you have your label, so you already have an idea of what you want to achieve. That's supervised. For unsupervised, you don't even have an idea. You don't have your desired outcome, You just give your machine, I don't know what this is, just looks for it, and it kind of groups this data into different clusters based on their similarities and differences. And we have reinforcement learning. This is all about teaching your machine to learn from experience. So the more it does it, the more it gets better. So if you penalize the model is being penalized for wrong prediction and is being rewarded for good predictions. Then we have deep learning as a subset of machine learning, where in deep learning, you have structure-like things like in form of artificial neural network that learns patterns in this data and comes up with solutions. So they are more complex and more advanced than our regular machine learning. On the other hand, we have data sciences. Data science focuses around using scientific statistics and your computer programming to to get meaningful insight from your data. I like a lot of us are already doing data sciences. If you are dealing with data, analyzing data, be it seismic, raw data, log data, these are all data sciences. But in this case, we're just introducing you tools that could help better improve our workflow. Then we have data analytics as a subset of data sciences. In data analytics, you kind of focus on a particular business need. You examine your data to get trends and make conclusions from those data that will be useful for the business. And we have big data. These are data that are too big to fit into our computers, our phones. They are bigger than our normal megabytes. They are in the ranges of terabytes, petabytes, and most times a dedicated data storage system is reserved for big data. And there is the data engineering part of it. Data engineering is basically transforming your data, extracting your data, and transforming it to make it usable by data scientists or data analysts. Normally, data come from different sources in varying scales, varying resolution. The job of a data engineer is to take this data, transform it, extract it, make it, clean it up so that it can be used for analysis. Now, having talked about what artificial intelligence is, let's bring it back home, the energy industry. Like, the world is changing, and one of the key drivers for this change is technology. In different industries, artificial intelligence has been used to better improve processes and make meaningful decisions. It could also be applied to the energy industry. Within the industry, we have lots of activities, we have lots of data, we have lots of processes, workflow that we've already developed. AI can help improve these processes. So one of the importance I say here is automation. Within the industry, we have lots of time-consuming, repetitive tasks that could save time, that could cost time and labor. But if we're able to automate some of these processes, we'll save time, we'll save labor, and save cost. And also, our operations, as humans, we are liable to errors. So if we're able to automate some of these processes, we're able to eliminate some of this human error. And as humans, we are biased humans. Like what a person A would call something, a person B would call it something else. So this can introduce bias into our processes. If we're able to automate these processes, we are able to kind of eliminate these biases. And also, if we're able to automate our processes, the time humans would have used to do some of these repetitive tasks, we used to focus on other part of the workflow that the machines can handle, thereby optimizing and efficiently utilizing these human resources. Also, we have data optimization. Within the industry, we have lots of data, some in dormant formats that cannot be easily utilized. So with AI, we can easily digitize this data. An example are if you agree with me, some of our old PDFs, our old logs, images are in scanned PDFs or scanned images that cannot be easily digitized. But with natural language processing, it's AI-based, we can extract this data from this information. So rather than it being dormant, stored in books or somewhere, we could also use it to improve our process. And also, we could also use AI to reduce complexity in our data set. Like the industry is a multidisciplinary industry where you have different disciplines trying to collaborate to make intelligent business decisions. And these different disciplines, they come with different data, and this data can be in different resolutions and scale. So, and they also have high dimensions. So trying to kind of bring all this together in one space, doing this manually could be somewhat difficult, but with AI, those complexity in these different data can be adequately handled. Before now, focus has been on fossil fuel, oil and gas, but in recent time, because of concerns around the contribution of fossil fuel to the greenhouse gas emission, focus has kind of shifted from oil and gas to other energy transition fuels to include into the energy mix. So we have solar, wind, we have geothermal, we have carbon capture, utilization and storage, we have nuclear, we have minerals. So it's a whole lot. So in this place, in this slide, I'll just be telling you different processes and how AI can be used to improve those processes. So it depends on, I know not everybody here would fully involved in oil and gas. So we have other people within industry so that this can be also we could also communicate better. So we have forecasting weather and climate conditions. Within the industry, we have for solar and wind energies, like this is applicable to solar and wind energy. You need to understand your weather conditions because this energy source are reliant on weather. So for solar system, you need where there is sun, and wind energy, you need wind. So with AI, we're able to forecast weather condition in different regions, so to know where to focus for these energy resources. We also have multivariate analysis. Most industries or most energy sources require analyzing different variables. So with this, we can AI can help in multivariate analysis. And we also have optimally locating our facilities. Most of our processes require installation of one facility, either production or different facilities in order to produce this energy. So with AI, we're able to optimally locate these facilities in the best position. Also with AI, we can help in predictive maintenance. So rather than waiting for your machines to fail, AI can give you intelligent decisions on how, when a machine is to fail or a facility is to fail, so that you appropriately maintain them so that they don't fail on you, which could, so it's applicable across all the industries we have. We also have environment. AI can also help in the environment, controlling the environment by controlling hazard control, where you have maybe landslide, earthquake, tornadoes. With AI, you can predict the occurrence of these and prevent them. You could also predict for soil or water pollution, know where when you use your satellite imagery, you could all use it to monitor your environment to see how things changes over time and how you can control these changes over time. So it's applicable across the different industry. Also, we have surface analysis. AI can be used for geological mapping. You could use it for remote sensing and analyze or interpreting your satellite images. It's currently being done. And finally, we have subsurface analysis. You could use AI to predict your fluid flow. You could use it for reservoir resource management or uncertainty analysis. So in my next slide, I'll be talking more about subsurface analysis. So within for subsurface applications, we have different phases. We have the exploration phase. With AI, you could use AI to enhance your exploration. So you could use it for your basin or petroleum system analysis or reservoir modeling by using AI to delineate reservoir structures. So there are machine learning models where you can interpret faults or your structural configuration from your seismic using AI. You could also use AI for reservoir characterization. You could use AI for well log interpretation, trying to get your lithologies, your lithophases, your stratigraphy across your well, even predict for porosity, permeability, water saturation, just to help your volumetric estimation. You could use AI to analyze core photographs, and with AI, you could also use it to pinpoint where exactly to drill where you have your oil and gas accumulation. This is more like a machine learning workflow that has been used for exploration through to development. So we could also use machine learning for drilling to optimize your drilling to provide exactly where to drill and how to drill. It can be used for precision drilling to prevent accidents or blowout in your rig. You could also use machine learning or artificial intelligence for drilling automation. AI can also be used for reservoir management, understanding your reservoir, carrying out simulations, normally simulations that you could take a long time to do. In split seconds, using artificial intelligence, you could use it to carry out multiple reservoir simulations. You could also use it to survey your reservoir, to understand your reservoir performance through time, to know why your reservoir performance is low, and just kind of help also maintain our facilities, like I said initially. It could also be used for production, so to help monitor your production wells, to see areas where you have low performance of your well, to see where you have maybe high water cut, or when you have issues with your tubing. With AI, you can intelligently kind of locate where maybe you have a broken tube or something like that. You could use AI to predict for that. So different companies are already doing different things when it comes to AI, like Total went into partnership with Google to optimize subsurface data analysis. Shell, they are using machine learning to help precision drilling. ExxonMobil partnered with MIT to come up with robots to detect oil seep and also for ocean exploration. BP and Spark Cognition, they also have this collaboration where they are kind of research in order to predictively to boost productivity of our reservoir and also help with predictive maintenance. Sinopec, they are also doing a lot with AI, trying to build smart manufacturing platform. So a lot of companies are already embracing AI. They've seen that AI is a future, and with AI, you can better optimize the processes we already have, and they're already keen into this. So now, having talked about this, what AI is, its application in the industry, and what different companies are doing regarding AI, we just want to talk about what are the challenges, even though we know that it's the future, it would help improve our operations. There are still challenges with this. So we'll be talking about the challenges in the next few slides. But something I want to let us know, behind every challenge, there are opportunities. Yeah, beyond us, one thing I want us to take from this is, even as we talk about challenges, I want us to see opportunities and see how we can leverage these opportunities to become better professionals to impact our industry. So the first challenge I'm talking about will be automation. Everybody believes AI can do everything, but unfortunately, not everything AI can handle. So we should be able to understand the processes that need automation and the processes that humans still need to handle. So in order to understand this, you need to evaluate your problem that needs to be solved, and you want to focus on those repetitive processes with no variable output. So your output is not dynamic, you have more static output. For example, maybe lithology interpretation, seismic interpretation, those are to a reasonable extent kind of not dynamic in the sense of the output. So those are some of the tasks you can give your machines. And also, not all automation involve machine learning. Some automations just require programming, not necessarily machine learning. Our second problem, I think this is a very big challenge everybody's faced today, is data. Data is very critical. The nature and the type of data you have is very critical in deploying artificial intelligence in the industry, because it's more like if you give your computer poor or incomplete data, you don't expect to get the best result for your data. So we don't really have enough labeled data set or machine or artificial intelligence worthy data within the industry. Some of these data are incomplete. You have maybe missing data, incomplete log, or you have seismic coverage that you have some. So these are some kind of challenges that can be can affect our machine learning or artificial intelligence. Some of our data are noisy and the quality is not so great. And some of these data come with a level of uncertainty associated with them. So some possible solution is, first of all, we need more geoscientists to go into data engineering. Like I said initially, data engineers, they look after the data, they transform the data, make this data ready for machine learning engineers or our data scientists. So as geoscientists, we already understand our data, we understand the uncertainties associated with data, we understand the problems associated with this data and the end goal of this data. So we have geoscientists doing this data engineering, they are able to transform this data from knowledge based on what they know and give insight. Also encourage collaboration. Different companies have kind of different data. So I'll encourage collaboration between companies to build maybe like a big warehouse where we have lots of data that could help improve the processes. Because for example, you could have maybe say a geographic location, you could have company A having seismic data in a particular coverage and company B having data in different coverage, or even maybe within the same area, company A would have maybe seismic data and company B will have a different kind of data. But bringing this data together, if there is this collaboration, you are able to see wider coverage and have more data that could better influence this machine learning models. We also need school and companies collaboration. This is still a new field within, like data science is still pretty much new within the industry. So it's still open for research. So we need these companies to provide schools with the necessary information or the necessary resource they need in order to research and come up with unique solutions that will impact the industry and improve our workflows. And the next challenge is talking about e-voice problems within the industry. Like there are lots of problems that are not properly, you can't really define. Number one is lack of ground truth. There is no, this is the ultimate result. It's just based on the data. Like for the subsurface, we don't really know, understand. Nobody can come and say, oh, this is how the subsurface looks like. It's just based on data. So the more data you get, the more you transform whatever you are, the more you transform your model. So this lack of ground truth can also affect applying AI in the industry. We all have heterogeneities within time and space. You have maybe within a particular, if you use this, if you drill in a particular location, for example, you'll see how the geology changes over time, even with the same location. This happens over time and over space. So there's this heterogeneity across a particular region. You could also have geologic processes that also affect this, like sea level changes, glaciation, all those things, polarity reversals. This affects our geological process. So capturing this heterogeneity in AI could be somewhat difficult. Also, we have multi-resolution data. Some of our data come from different sources. They all have different accuracy associated with them. Some have high sampling rates, some have low sampling rates, and some have different uncertainty associated with the data. So analyzing all this data, bringing this data together could also pose a big problem, a big challenge in the industry. And you also understand that geoscience is a descriptive science, a descriptive or qualitative science, and machine learning and artificial intelligence works with numeric quantitative. So converting some of these processes, our descriptive nature of geosciences to mathematical forms could also pose a big challenge. But for some possible mitigations to these challenges, I would say, again, we need some geoscientists to become aware of, know what data science is and understand the processes involved in data sciences and machine learning. Currently in the industry, a major part of people doing this are mathematicians or computer scientists, people that have no knowledge of the data. So they are learning on the job, learning about, but geosciences is a very kind of unique science that no matter how much you read, you need time. But we already in this field, we already understand our data, we already understand our processes, we already understand the challenges with this data. So if we are better equipped with these skills, data engineering, data sciences, and machine learning, we're able to process and even handle this data better. Also, we could also develop algorithms. So rather than that, we could work with different resolution. So rather than trying to upscale or upsample one sample to meet the resolution of another sample, we'll just come up with algorithms that can capture these different heterogeneities, these different resolutions in our data. So finally, we'll talk about I just divided my challenges into 4: automation, data, e-voice problem, and industry reception. Like generally as humans, I say we are very kind of resistive to change. The industry is a kind of a matured industry in the sense that you already have well-established principles, well-established guidelines and processes. So there is this, can artificial intelligence do these things will develop in years? Yes, so it's still been, so you find out that when you want to talk to clients about AI, they are kind of not so sure of what the outcome is. But I think if we have more geoscientists in this field, I think these people would be more confident in the process because we already understand these processes, like the geoscience processes, the oil and gas processes. So we're just using machine learning. So it's different when somebody that understands this process is trying to bring in something new than someone that's just coming from space that don't really have, there's no well-grounded in our normal processes to come in. So I think if as geoscientists, we could go into this, there'll be more confidence that we are able to appropriately capture the differences, the varieties, and the uncertainty associated with our data, and also just to create awareness that machine learning is not yet to take away people's jobs. I know that's a lot of fear. But it just helps optimize the process, optimize our workflow, so that I'm doing things that can be done in split seconds, spending weeks or months doing things that can be done in split seconds. Why not give the machines that are you focus on other challenging parts of the workflow that machine can handle? So at this point, I'll just end this presentation here and open the floor for conversation. I'm very sure we all have different experiences. We all have our different thoughts and thoughts to everything I've talked about. So I will yield the floor open for conversation. Thank you.
Thank you so much, Promise, for your presentation. Okay, I think some hands are up. Okon Divine, please, you can ask your question. Then after which Yomi can follow up with the question as well.
Promise.
Yeah.
Good morning. Okay, good afternoon. Yeah. Fantastic one, man. You delivered it properly. No better way to put it. But my concern is the data engineering part. So you mentioned something about the problems you have, which is data collection, data storage, which is totally very true. I remember the last time we worked on the project, I had to call Ifeanyi to give me someone's number for me to get certain information, certain data sets I needed, so I could actually build the predictive model I was working on. That's true. So when, in terms of specificity, when you see data engineering, what skill set is required to be a data engineer? That's one. I just want you, I'm asking the question so that the floor will be open, because most times you could see a lot of data scientists, they can't actually define that role properly. We know what a machine learning engineer is, we know who a data scientist is. But when you say data engineer, it's very confusing. I did a job once. I was told that the role was supposed to be for data engineering, but I ended up doing everything. Everything I did there was a cloud engineer, writing server-side programs for the cloud and maintaining data in the database. So I want you to, in terms of specificity, clearly define the roles and the skill sets involved in data engineering, so that it will be easier for people to pick up the skill set and finish it. Are you getting me? Currently, I write a program called, it's called, one of the skill sets I know, just to kick it off, it's writing what they call Airflow, Apache Airflow. I don't know if you have heard about it. Yeah, so basically that's one of the routine skills needed for that field. So just to keep the floor open so that you can actually clear that point. Thank you.
Okay, thank you very much. Like a data engineer, just simply put, is somebody that looks after data. So everything you need to collect data. So depending on the industry you are, data engineers collect this data, store the data, they take care of the database. So the data is more like their baby. They try to maintain this data for data. So there, in some companies, data engineer, data scientists, they are interwoven, but in specific terms, a data engineer collects data, looks after the data, cleans the data, transforms the data, and store the data for a data scientist to use. So you talked about Google Cloud, Aperture Airflow. So those are tools that data scientists use. So if you want data engineers use, so if you want to be a data engineer, some of the skills you should be focused on would be your SQL or NoSQL style structured query languages. So these are some of these programming language you want to know. You also want to use Python. They work hand in hand. So there are other kind of libraries or tools that data engineers use to optimize their processes, like the Aperture Airflow you talk about is for scheduling. So for example, those people that collect data from websites, so you could just schedule, okay, every morning, download this new set of data that has been uploaded on this site. So to put it in clear terms, they transform, load, and look after databases. So you have some cloud-based database, you have some physical databases. So any of that, depending on what the industry or the company is using, the data engineer handles that. I don't know if that answers your question.
Yeah, it does. It does. I just wanted you to state it out since you're in the industry. So, okay. Lastly, before I go, sorry, I won't ask again. Lastly, so in a bid to solve the problem we're facing, which is basically a data center for collecting data. Now, let me give an instance. If I want to look for census population data set, I know where to get it, basically, because it has been stored somewhere, and APIs have been built already and easier for me to consume. So, but when it comes to data science, how do we, I think when it comes to geoscience, how do we create policies around aligning this kind of collaboration, where we can have open source databases with APIs available for our consumption for every type of data we want? So do you know about any policies we can, or what we can do as young scientists with the help of NAPE to actually push these processes so that it will be easier for us? It's very difficult. It's easier to say you're a data scientist when you haven't modeled real life data. I create synthetic data all the time because I can't even model, because of the process of trying. I don't have, show me a geoscience database where I could actually consume any API. I can't find it. Okay, so how do we solve that problem? So I want to hear the policies if you have any. Thank you.
Most of that is beyond us, not something I say I can do. So it's just to create awareness and maybe educate the necessary bodies in charge of this too. Okay, this is very important. If you want to move this industry forward, we need this warehouse where we could, different companies come, bring your data, we transform the data and see how we can push AI in the energy industry. So for policies, I can't really up to the top of my head say this is the policies, but what we can do is just to continue creating awareness. Okay, what are the advantages of this? Doing presentations like this, in whatever capacity you have, present to NAPE, they take it to the necessary body. So it still boils down to the country data repository system. Like in Nigeria, sorry to say, I don't think we have a great data repository for public consumption. In the North Sea, for example, if I want to, let's not talk about machine learning body data. If I want to get well data, seismic data, I know where to go to get. I can get seismic data of this well data for different fields in the North Sea. They are stored somewhere. But in Nigeria, sorry to say, we don't have that. So those are some of the processes that, some of the conversations we need to keep having. How can we? So we need to solve that problem first of having data available then before we start talking about transforming this data to be usable for artificial intelligence or machine learning. So these are conversations that are ongoing and we still need to continually push for it.
Yomi, you can ask your question, please.
Well, thank you very much. Thank you to the presenter. It's quite insightful. Okay, one thing I would want to ask, maybe my question will be divided into about two parts. And the first one is this. I'm glad you mentioned, you talked about the place of, you creating awareness and letting people know the need for data scientists. Many a times when the concept or when data science is mentioned, or when machine learning, AI, and stuff like that, are mentioned, it looks vague, should I say, to quite a lot of people. And sometimes when we go online, maybe for laymen, I want to make my question as simple as possible or as base as possible. Sometimes, when we go online, or embark on search for information, it looks like people get more confused, so to say, when they come across, series of information. So I want to ask for a person like you that is in the industry, maybe some of us are in the academia. Yeah, for a person like you in the industry, what would you advise before a starter who is interested in some of these areas that you have mentioned in terms of maybe the basic mathematics, maybe the basic programming, and the areas to look into when it comes to programming and mathematics, and so on. Maybe you should take the first question before I ask the second question. Thank you.
Okay, yeah. So there are lots of materials available online where you could. There is on YouTube. There are lots of channels. Like I have my own channel where I'm talking about this. You could go on Udemy. There are some courses. So you may not really currently have the application to the energy industry in particular. So that's something I'm passionate about. That's what I'm trying to build. But currently, you could just go and learn these days. So if you could learn the principles, most of these are if you don't like mathematics, data science should not be something you should be looking at. Just that's on a lighter note. They already have background principles. So if you could learn those principles, understand what data science is, so you could also bring that concept to the industry. So first of all, you just want to go learn programming, understand what programming is, learn a programming language, be it Python, R. So if you are interested in data sciences and just want to focus on data sciences, you want to focus on maybe Python and R. If you want to go into machine learning, you want to look into Python basically because Python has better machine learning algorithms. If you are looking into data engineering, you also want to include SQL or NoSQL, that's structured query language, is for databases. So these are different, learning these tools, there are different materials online to learn this. So that's the first step to understand this different. First of all, go learn a programming language. Then under these different programming languages, they have different libraries that you could use for different things. And a lot of these materials are available online for consumption. Yeah. So some are paid, some are free. So it just depends on it's another thing I like to say, if you want to go learn these courses, don't just jump. There are lots of courses that are not really relevant. Like before I started, I think I've talked about how I started data science journey. Initially, I was just jumping on everything, paying one or pay. So there's some courses that are not really necessary. So before you pay or register for a course, you want to go through, maybe consult someone already in the field to say, this is the course I want to take. Do you think is appropriate for the level I am? So to say, that's our advice. Yeah.
Thank you very much. May I go ahead with the second question? Yeah, the second question is, should I say a bit, I wouldn't say a bit academic, but I would try and make it as base, as possible as well. Yeah, I was privileged to attend a class some times ago by one of the guys that are into maybe machine learning for reservoir characterization and stuffs like that. So one of the questions, I asked them, because though currently I'm into passive seismics, earthquake, seismology, stuff. But of course, being a Nigerian, the basic background, we all have is, petroleum exploration and stuff like that. So one of the questions, I asked them was that, because most times when they present stuff to us, what they keep, we are too familiar with, there's one model called Mamosi model. So we are very familiar with that. And so I was like, okay, have you tested some of these, your methods, maybe with real data? Because someone mentioned synthetics the other time because of the paucity of some of these real data. And, I asked if they've tested some of their methods, some of what they've developed with real data, and if they've been able to compare the method with, compare their results with some of the well-known, established, and conventional methods that we have been used to, and if they've been able to, to compare and check, the result out. Because, and also from your presentation, you mentioned something, about the North Sea, because we know that the geologic configuration of the North Sea is quite different from what we have in the Niger Delta and maybe GOM and some other parts of the world. So in the light of this, So I want to ask, you being a Nigerian and very familiar with that terrain, so having applied some of these new stuffs to maybe some data, do we have, how reliable are some of these, ML techniques to having very robust results, reliable results, when we use them for some of the stuff that we've been doing conventionally before? Thank you.
Okay, yeah, thank you for that question. Everything still boils down to your data. So that's why I kind of emphasized on data. If you have kind of poor data, you don't expect to have the best results. So talking about applications, for my master's, my research I did, I used well logs to predict lithologies, like using your normal gamma ray log, resistivity log to predict lithologies from well logs, just in a similar way model we do. So from that research, I discovered that even the machine learning, the data that was given was not so great because you have some inconsistency or wrong labeled in the results, in the data provided. And you found that the machine learning, even despite the poor data quality, the machine learning was also able to even give correct predictions, even where the human label lithology was kind of not totally correct. So I think if you have good data, there are good possibilities of improving our current processes, of getting even better results than we have already within a shorter time rather than spending time. So I know that there are possibilities, the chances and the possibilities are very high, and it will definitely improve, but it still takes, we are still in the building phase. We still need a lot of work in order to get that ready. We need to get our data right. So that's what I'm preaching. Let's get data right. Once your data is right, every other thing would be easier from there. Yeah. I don't know if that answers your question.
Okay, let me add more to that, Mr. Yomi. One thing I think your concern is very valid. Some people have shared that concern with me. I will give you an example, a classical example of how this thing works. If you look at your seismic inversion, for example, the conventional method is this: you build low frequency model, from your logs and stuffs. Then you do your seismic inversion. Now, for deep learning or machine learning inversion, what you do is to build a model, a test model. So that test model, it can be from your log. The machine learning algorithm will now use it as an input to look at patterns in the general data set. So like you said, it's also a function of your data, but you don't just run the algorithm. You give the algorithm something to work with. Promise, I don't know if I'm wrong. You give the data something to work with based on that prior data model. The machine learning algorithm will now help, instead of you manually, the conventional way of interpretation, the algorithms will now help you in the prediction, and it gives you a better result and better judgment. Remember that that control is the prior model that you put into the algorithm that you use for your predictions. So that is what for me, and for you to understand that, please, it does not take away your geological knowledge, because at the end of the day, you need to kiss your model and make sure that it makes geological sense with respect to your conceptual geological model. I keep telling people, geology drives interpretation, not the other way around. Because if I build the model, at the end of the day, it doesn't make sense to the conceptual geological model within that area I'm working at, again, they have to go back again and check my test model, check the parameters and stuff. Then you keep training it. Remember, she make a reference to supervisor. She gave several ways of doing this when she started her interpretation. So depending on the method you want to use at the end of the day, you still have to tie it down to the geology, that area you're working at. And you cannot take away your statistics, mathematics, and physics knowledge, because these are the fundamentals. For example, some of us that do conventional static modeling, those geostatistical algorithms, I see some of those things that is being improved upon and stuff like that. So it's still tied down to your local geology. You don't just use machine learning and run it like that. You still need to look at it again. Does it make any meaning? Does it tie to your geology? Does it tie does your data even make sense? So it doesn't take away your residual knowledge at the end of the day. Because some people have been thinking that probably it is going to cut down on job opportunities. If people will no longer get job if machine is doing that. No, machine, you still have a job. You still need to QC the result at the end of the day, to make sure that the reality of what you are working on the environment you are working on, makes sense in terms of the model.
Yeah.
Okay.
Yeah. So,
If
yeah,
I
so
can I? Okay, finish.
No, I just wanted to add to what Ifeanyi just mentioned. So when you're training your model, you reserve a particular data set. So when you have your training data, you reserve a percentage of your data to use in evaluating your model performance. So you don't just train your model and say, okay, go and start working. So you have to test the data, the model, to see how is this model performing. And also a good machine learning model is one that is both data-driven and knowledge-driven. So you don't just rely on the data alone. You also need to include your knowledge. What's your domain knowledge? What do you know about that? Combining that with the data will provide better AI models. Yeah.
Okay, sorry. One more thing again. Ifeanyi and Promise has said everything, but just to add, now why machine learning is very important. One is the idea here that we can actually automate the keyword she mentioned. Because it's taken for granted. The fact that you can do this stuff as at the go. So imagine you have tested you have taken a part of the data sets to actually test. You learn from the pattern and you want to actually predict. Now, you can actually do what they call optimization. They call it hyperparameter optimization. Is that true? You do optimization. As we also have metrics to actually check if the test data matches the pattern. So you could actually use these metrics, like if you're using supervised learning, you talk about things like commission metrics, recall, precision, and the rest. So the idea here is you have metrics to actually checkmate you at every point in time seamlessly. And those metrics too can be automated. So everything can just be done while you're sitting down, focusing on something else. So that's the beauty of this stuff. And I feel it's underrated. So that's what she's trying to say. Thank you.
Yeah, thank you, Divine. That is perfect. Yeah, Prince Way.
Hi, good morning. My question is based on getting into a career of data sciences. You well know, Promise, that it's very difficult for us in Nigeria to get to technically be trained in data science. And to be very honest, I've been hearing these stories that you will go online and be reading about details to become an AI specialist or a data scientist, etc. But to be very honest, it hardly works. And you have to be proficient either in a master's in data science or in a course-specific program. So in this case, when we young professionals see all of these jobs with respect to data sciences and AI, and we know that we actually want to even to work there and to learn it, is it okay to still apply, given that we do not have the necessary training? Probably we'll be gambling with the fact that we could get an opportunity to learn on the job. And if that is the case, do you suggest we go to look for those opportunities? And what do you think we should have in the meantime to at least get an opportunity to learn in the job if we cannot afford a master's at Imperial College?
Yeah, just to correct that, I did study machine learning as my master's. My master's was petroleum geoscience. So I only did my project in machine learning, and I had to go learn by myself. So what I'm emphasizing is learning. Currently, you wouldn't really see somewhere to learn where you apply AI in the industry. Just go and learn the basics of AI, machine learning, data sciences. So if you want to apply for a job, at least you should have background knowledge. Nobody's saying you have to be proficient in machine learning or data science, at least understand the basics. Can you have a conversation? So if they ask you some basic things about data science or machine learning, because if you're going for a job in data science, they will ask basic questions, right? So you should be able to have that conversations. So these things have their background principles, mathematics, statistics, programming. Go learn these things, understand the principle behind data science. So I think if you are able to get the principle, you can apply it anywhere. So what I did when I did my thesis, I took Udemy course. It had nothing to do with energy. It had nothing to do with the oil and gas. I just understood the principle that backed machine learning, data sciences, and artificial intelligence. Using that principle, I brought it back to applying it within, because I'm a geologist. I work in the energy industry. So I need to bring it back home. So the idea is just go learn, understand the basics behind these things, I have conversations, and you can definitely come back to apply it. Yeah. So it's still the AI in the industry is still in the building phase. So it's still a lot, there's still a lot of groundwork to be done. But what I'll just advise, just go learn it, train, test data. There are so many data online. So if you go to Kaggle, if you go to Stack Overflow, there are different data. There are even machine learning models. So these are platforms or forums where people have conversations, interaction about this. So you should go there. If you have questions like this, the Stack Overflow is more like a data science Bible. Every day I still use it. I just go, I want to do this, how to do this with this, with this. You see different options, and you could, since you already understand the principle, you could go through the different solutions and see the one that is applicable to your own particular scenario. Yeah. So I don't know if that answers your question.
Yes, it certainly did. I never saw it from the angle of going to learn data science in a more generic way before coming to apply it in geoscience. I was just thinking that I could just go learn it in geoscience per se, and lower log data and the like. So I guess I'll have to change my approach, go towards the generic method of learning like the Udemy, and hope to get it from there. Thank you very much, ma'am.
Oh, thank you so much.
Okay, in addition to that, I will give you my own personal example. I work with Aliborton. It is not, my job description does not involve, coding, building algorithms and stuff like that. My job description understands, just like Promise said, the fundamentals and stuff, and I apply the algorithm to do my job. So if you are focusing, for me, it is the job of the R&D, the research and development guys, to do the question you're asking. So if you are going with that mindset, you'll be confused. So just like you said, just have a broad knowledge. And remember, it's not limited to only oil and gas industry. You can apply it anywhere. Anywhere. I gave a lecture to NAPE-YP Calabar chapter a few months ago on the deep learning seismic inversion. Did I develop it? No. Do I have the knowledge? Yes. So don't just limit yourself. And secondly, again, I would advise that, you can reach out to her anytime. You can check her YouTube channels. She have so many videos she have uploaded on AI, machine learning. You can subscribe. You can go there as well. I also have Divine Okon here. Divine Okon was, he also facilitated the Python programming class we did last year. We have so many resources within the NAPE-YP community that you can always reach out for proper guidance and mentorship, because that's the essence of the community. The essence of the community is not just for us to come and organize technical series, do training, go to NAPE conference. One of the essence is for you to network. If you have any challenges, you reach out. Please, who can do this? Who can do this? That's the essence of us connecting. We have the resources. We have young people within NAPE-YP community that are sound and grounded in these areas. So you just reach out. Reach out, because if you actually reach out, you won't have this, confusion you are having. Please, after today, reach out to Promise. I know she's willing and ready to, to assist or guide you. Okon Divine is here. We also have Sylvester, which is in US at the moment. These guys are doing so much, doing so much in the area of machine learning, artificial intelligence. Please and please and please, let us leverage on the opportunity you have as young professionals, so that they can guide us and, and impact us while we leverage on any opportunity that is around us and stuff. So I don't know if it's clear, Mr. Princewell.
Very, very clear, sir. Thank you very much. I attended the Python machine learning with Divine that last time. So
okay, that is awesome.
I'm coming up to speed, but I guess I'm a very slow learner. God will help me.
Please, it doesn't end at the end of the meeting or end of the training. Always reach out to them. I can assure you that they will be willing and available to guide you if you have any challenges. Always reach out to them.
Yes. I've been
Okay.
following up on Promise for quite a while. She's my
Okay.
connection on LinkedIn. I'm very happy with her update. So
Please
it's
go to our YouTube channel, subscribe to our YouTube channel, send to friends, let them subscribe, and always
that's
go there and check
exactly
out
the
our
next
videos.
thing to do. Yes, the YouTube is the next thing. Thank you very much, sir.
You're welcome. Nkechi.
Yes, thank you so much, Promise. I really enjoyed your presentation. The question I have is, you said you're a data geoscientist, and I don't know if this is a question you would want to answer, but what does your day-to-day workflow in your job role look like? So what should people who want to work in, should I say, that kind of role, what should they look forward to? What do you do exactly? What does your workflow look like from day to day?
Okay, my current role is I'm working in the geothermal industry, so not necessarily the oil and gas currently. So it's something that it should be open-minded, because every day comes with different things. So data kind of evaluates this data. So it should be open-minded, because different data set comes with different challenges. So I should be able to collaborate with your colleagues and people within the industry, and be open to asking questions, because sometimes you encounter challenges that you yourself can't solve. So you should be able to collaborate with people. So it depends on the particular industry you are. Some people I have colleagues that work with seismic data, working on seismic processing. I'm still not sure about that. Working on seismic processing and different things. So it's like, one good thing about machine learning and artificial data science is, like if I mentioned, it can be applied to any industry, and this different industry comes with its own uniqueness and its own processes, and there's still that background way of doing things, but the applications could vary. So yes, so that's it. So you could be working with seismic, but major thing is you should be open to learning, open to facing challenges, and should be able to, rather than back away from challenges, you should be able to face it head on. And also collaboration is key. Asking questions, reaching out to when you need help is very important to survive in this role. So I don't know if I've been able to appropriately answer your question, but that's like, so my everyday job. So it depends on, today can be this, tomorrow. So it keeps changing, it's dynamic, and just depends. So sometimes I still do data engineering work. So while I'm a data scientist, sometimes if I'm faced with a data engineering job, I get to do it because that's what the role requires. So you should be able to you should be dynamic and be flexible to change. Yeah.
All right, thank you so much.
Osahan.
Oh, good morning, Promise. I really enjoyed this presentation. Your approach today have made it more clearer and more simple, especially for those of us who are just trying to get more understanding about this. But there's something I want to be clear of, because during my undergraduate days in the campus, I did a course on operational research, and it was purely mathematics course. It has to do with minimizing cost for industries and all of that. But coming back to how you have broken down the artificial intelligence and bringing it, relating it back to the origin mathematics and computer science, because for what I observe here, most of our companies, especially those who are the non-energy industry, one of the challenge they have in new innovation like this is what the financial implication and the input it will add, the value it will add to their company financially. So I don't know how you can marry this, or how you can balance this for those who are not in the energy industry, and how, in what way can they really embrace this in a way that it will be attractive to them?
So I think I covered some of that in the presentation. The idea is to save costs and save time. Just imagine you have let's say you have 10 employees and you need to do a particular job to maybe interpret seismic, and using humans, you could just do that for, let's say, 2 weeks or thereabouts. Maybe somebody interpreting that for two weeks or maybe a month. just imagine how much you pay the person per day to do that. But if you're able to get a machine to do it in split seconds, that the 2 weeks that should have been used to do what the machine did for split seconds, they could also use it to do other things. So it's saving time, it's saving costs. And you are like, sometimes when you are able to automate some of these things, some kind of human errors would be eliminated in the process. So the general idea is to make life better and allow, rather than doing something that you keep doing over and over again, you just give that to machine while you do other things to improve and make the process more effective and efficient.
Okay, that was quite all right. That is okay. But the only challenge we have here now is bringing the information, the data together, having a reliable source of the data to work with. Because from what I see, AI will be very more efficient when the data is available. But when the data is not available, then the aspect of the human efforts cannot be underestimated.
Yeah, so it's just about investing. So now, like, we are in the building phase, so we need to invest. So it's more like a long-term goal rather than a short-term. So we need people to invest in this, and when you have it, so it's something that when you have it. So yeah, so that's where we are right now.
That means the point is, at this stage we are, especially over here in Nigeria, investors should focus more on building data storage,
Databases, yeah.
Database for information before. So this, if for instance, if you are to launch a campaign exercise on artificial intelligence on industry, especially those, because for the energy industry, most they are aware of this, but most of the non-energy, especially in the geoscience, the other aspect of geoscientists, a lot of they are yet to give attention to this aspect of the new phase. So if we are to carry out as an association or young professional, if we are to launch a campaign exercise, I think these are the areas that should be focused on.
Yeah, so we need to create the awareness. So that's the awareness stage. We need to create enough awareness there.
We focus on encouraging investors to invest in database, because the information has to be available first before artificial intelligence can come in. All right, thank you very much. That was a wonderful one.
Thank you.
Okay, Akim. Akim Adigun, please ask a question.
Hello, good morning, everyone.
Good morning.
Yeah, this is Akim. I promise, thank you for the presentation. Very nice insight. I just wanted to correct the notion that there is no data bank in Nigeria. I posted something around NDR, but the link showed else. But I tell you, when you apply for seismic data at DPR for your projects, the letter actually really goes to NDR, Nigeria National Data Repository. If you tell me it's not effective, yes, I agree. If you tell me it's not up to date, yes, I agree. But to not mislead some of our younger colleagues around not having, I'm not saying you are mistaken, I'm saying that just so that everyone have that right perspective, that there's an NDR that exists. And it doesn't just store health information, no. It stores statistics about everything: population, seismic, well data, any well that you drill today, the information must go to NDR through the old DPR, now the NUPRC or whatever it's called. So let us get that information right. If we need to improve on processes in the NDR, yes, 100%. If we need to update how accessible information should be, I agree. But I'm not sure we are at that stage of making information or data available in the public domain. Even Promise said something about the North Sea. The data that actually goes into that data repository that you see available in the North Sea. There's a policy that says every data that you have acquired 10 years ago must come to the NBR. That's what is happening in the North Sea. You will not find, except for specialized information, you will not find ongoing research or ongoing data use or ongoing data acquired on that repository. So if we need to put those policies in place that any data that you have acquired 10 years ago must become public knowledge, can be accessible to the public. Yes, those are policy solutions that we are putting to accessibility of data. I just wanted to get that out so that all of us will be informed about that. Yeah, thank you.
Okay, thank you, Mr. Akim, for that. I think, yeah, you are right. I remember the NAPE-YP Leadership Forum in Port Harcourt a few months ago. And these are some of the issues that were discussed. In fact, it totally skipped my mind. And I was also part of the planning committee for that leadership forum. Although you also mentioned one critical area, accessibility. So all these things were tracked out, and I believe that there's an advocacy going on in that area. And I believe that in the near future, some of those bottlenecks will be cleared. So yes, he's 100% correct, and I agree with him. Thank you. Any more questions, please? So, okay.
I think there's one in the chat box. Maybe you might want to go.
Please, can you read it out, please?
Okay, let me try and get that up. I think the question was from Uzoma. Good day all. Thanks, Matt, Promise, for the presentation. Please, my question is, from your wealth of experience, what's the role of data analytics in oil and gas, energy, and energy economics?
Yeah, I think it's everything we'll be talking about here. Oil and gas can help in automation. It could help in data optimization. Automation in the sense that some of these manual processes can be automated to save time and save costs. It can help in data optimization. Some of our data stored in PDFs that cannot really be digitalized or accessed using natural language processing, which is AI-based. You're able to extract those information and make your data more useful rather than lying dormant. It could help to reduce complexity in our data. So normally what some kind of hidden trends, because we work with different disciplines, and these different disciplines come with different kind of data with different resolution. So with AI, you could bring everything into one space and even come up with some trends that are not so obvious using our manual processes or traditional interpretation techniques. So the idea is to better increase the efficiency and optimize our workflows and our processes existing.
Hello, can you hear me, Promise? Can you hear me?
Yeah, I can hear you.
Yeah, go ahead. Okay, sorry. Yeah, please. Yeah. Okay, someone talked about the data being available. So here, from a more technical perspective, so there's what we call data security processes. We look at the CIA triad, we say confidentiality, integrity, and availability. So here, basically, he mentioned accessibility, yes, also, but we didn't talk about confidentiality and integrity. Now, let me put this from a perspective where we can actually understand what Promise, the point I have been making, and basically I'm sure Promise has been making, that data is not available. Now, there's what we call application programming interface. Basically, it's more like, imagine Facebook having the database, and you can actually use an API to access data from the database without spoiling anything from that database. That means they give you access to an amount of data you want, suitable for what you want to do. Imagine you're building a Twitter bot. You can get access to certain information from Twitter database you get without getting into a sensitive part of the database, then using that information to automate process on Twitter. Basically, maybe a bot that can tell anytime someone mentions, I want food, your vendor pops up and say, come on, I'm selling food. Now, let's put that processes in geosciences. Now, what's the essence of these organizations where we can have databases and APIs to access this information on real time? the point we've gone past that process where we have to write files and letters and go down. Everything should be done by single clickable processes. This is where automation comes in. Even if you have 1 million data stored somewhere in your office somewhere, no matter how it's stored, and I can access it when I want to access it with simple iteratable processes. It's not available. It's not available. That's what that's the point I am trying to make. That's the point I'm trying. When I say data is not available, or when Promises say, I don't know if that's the same point she's trying to make. So basically, we're in a technological phase right now. So we're looking at processes that can be seamless. If it's not seamless, it's not available. So that's the point. That's the point I'm trying to make. Thank you.
Okay. Thank you, Divine. Of course, some of these issues were actually discussed during the leadership forum, as there are procedures and laws that establishes these organizations and stuff. That is where advocacy comes in. I will keep interfacing. I will discuss with the UAPC chair, then with the NAPE top leadership, so that conversation will continue to go in this. Of course, we have a DPR member, as NAPE members, we have a DPR, NUPROC, members of National Assembly. So we keep on, it's an advocacy, we keep on talking to them for them to realize the current trend, the reality on ground, because they cannot go contrary to the laid down rule and, that govern data management and, accessibility. So we keep on reaching out, letting them know that this need to be done. So we'll keep on, that's where advocacy now comes in. So at UAPC and the NAPE main body, we'll keep on talking to them. And I think it's even good that some of this conversation is coming now, so that at least some people know that we have, like a data repository body in Nigeria, and the challenges in accessing data and stuff. So it's good that we're having this conversation, and we keep on reaching out to the relevant authority to be able to help us in making sure that things are seamless. I don't know if that is clear. Thank you.
Thank you.
Mr. Bestman, Daniel Bestman, you have a question?
Okay. Thank you very much. Good morning, everybody. Okay, my name is Daniel, and it's been a wonderful session so far, although I joined late. So my question is, I think most of the people that have been asking questions, they are like professionals, and they've, apart from the AI part now, they've handled data, they have experience in the industry. So I'm asking, what about those that have not really had any experience in the industry yet, and they want to transition into data geosciences? So how do you go about it? Because first of all, you have not used, or you have not worked with data, you have not worked in the industry, you have like losing experience. So how do you transition? How do you do it? Thank you.
Okay, if I attempt to answer that question, for young students that just graduating, that so at least you already understand the background to geology, to the industry from your course, I suppose. So we have community like the NAPE-YP community, we have NAPE organized technical sessions, you have people that you could reach out to get, kind of learn things about. So it's just okay, you already have the geology background, also learn the geoscience background, and with time, I think there are some kind of events, there are technical meetings, there are workshops that we organize that would also help you to build balance this, but you wouldn't just wait for that. Just start learning as much as you can learn, attend seminar, attend courses, attend presentations, and learn, and just find a way to balance it. So that's what I would say. Just if you already have the geology background, keep learning on that. Also on the side, start learning data sciences and the programming languages you need, and with time the opportunities will present itself for you to apply that. For some, like I'll just use my role for example as a data geoscientist. When they were recruiting, they were not looking for someone that has 100% knowledge of data sciences. They're not looking for someone that has 100% knowledge of geosciences. They just want you to know enough of both. So you could have maybe 20% each. So just have enough knowledge of both that you could at least hold conversations and do something. Then you can also always learn on the job and grow in the role, but you have to be enthusiastic. You have to be passionate about what you want to do.
Okay, thank you very much. Just another question. In terms of job opportunities, I don't know, I joined late. I don't know if you talked about it earlier. In terms of job opportunities, what are the opportunities in Nigeria? Are there opportunities at the IOCs and the rest? Are they willing to employ people in this capacity? So what are the job opportunities like? Thank you.
Yeah, I wouldn't speak for them, but I think it's an evolving community. It's like it's still evolving. So it's still like the next big thing that's going to happen. So I wouldn't speak for the companies, but I know that some of these companies in-house, they're already building, they're already doing things like that. It's just for you to position yourself when the opportunity presents itself, you're able to take advantage of it. So I won't be able to speak for these individual companies, but I know that companies are already working on these things, and yeah, just to be prepared when the opportunity comes to be able to take advantage of that.
Okay, let me add to that. See, there is active, I want to speak from the perspective of where I work. I work with Halliburton. And I can tell you categorically that so many things are going on in that space. For example, we have solutions, for machine learning driven fault interpretation, horizon interpretation, lithology prediction, name it. So many things are actually going on in the industry. So like you said, just keep working on yourself, keep reaching out. The essence of NAPE-YP, one of the goal is networking, giving you the opportunity to reach out, to get information. Because most times when we put up this technical series, people don't really see the value in it. Sometimes people say, I bet we don't tire for grammar, stuff like that, But the truth is that you never know when the opportunity will come. It might be just few things you pick up from Promise, lecture today might open up an opportunity for you tomorrow. Honestly speaking, So please, the NAPE-YP is not just some people. In fact, if you go to our platform now, we have close to 600 people. But how many people are present here today? To even listen to this conversation. So the reality is that the world is now going into digitalization, automation, artificial learning, even your software, cloud computing. So don't just limit yourself to the traditional base, but try to make yourself a global professional by following the trend. There are so many free, like you listed, so many free stuff on the internet. We have professionals within the NAPE-YP community. Promise is there. I make mention of Divine. You can always reach out to them for proper mentorship, for guidance and stuff. So it's not just adding on the WhatsApp group and our Telegram group. There are so many resources. We have had several technical trainings. You have them in our NAPE-YP library. You can reach out to us to have access to some of these trainings, materials, videos, and name it. So the resources are available. So it's not depend on you. You are responsible for yourself. So if it is there, just reach out to us, and we always try as much as we can to provide you with those opportunities and stuff. I think we are going to end it here today. And also, please, I want to encourage us, please, Promise has a YouTube channel. Please just kindly subscribe to our channel. She has so many videos she has posted there, so many lectures on artificial intelligence, machine learning. Just go there and listen to those videos, follow her. You can reach out to her anytime, and you can start from there and take it off from there. This I don't know if you have your YouTube, you can post it on the chat box or something for people to get that, and try to follow you on the YouTube channel, or you can project it on the screen for them to see. Please do not be stingy with knowledge. You can send the YouTube channel to maybe if you're in school, to your classmates, your friends, your colleagues. Let them subscribe and get as much knowledge and information, because she actually broke them down. If she broke them down, it will be easy for you to learn and grab, and she's readily available to respond to your questions. And she's also on the NAPE-YP platform. You can always send a message via WhatsApp and she will respond. Please, if you can share that probably on the screen or the chat box so that people can go there and follow you.
Yeah, so I've posted the link to the YouTube and the chat box. You could also reach out to me on LinkedIn. and on WhatsApp, like you said, if you have my contact. I'm open, I'm passionate about this. So if you're reaching out to me concerning this, I'm readily available to answer to you.
Okay, Adobe, I'll give an exception to just quickly ask and we'll end the call.
Okay, thank you very much, sir. Good morning, everyone. I already dropped my question in the chat box, but I'll just repeat myself. Ms. Promise, thank you very much for the session. Although I joined late, my question is, what data and programming languages would you recommend for budding data scientists like myself? Thank you.
Yeah, so I would recommend Python, basically Python. Though so you could also do R programming language, but for me, I'm working with Python. You could also learn a bit of SQL. You don't have to just, because sometimes depends on the company you work, you may want to query data, maybe get data from databases. So you will need SQL to get that. You also have SQL embedded in Python. So I'll just tell you, learn Python. I think it's easy to learn. It's more like, it's not as difficult as people project it to be. So it's Python R, that works for you, but Python, because you can easily work with, a lot of people use Python, so yeah, easy to collaborate with people. So yeah, Python.
Thank you so much, Promise, and thank you guys for coming to this section. Thank you for your time. Promise, of course, I know that when we call on you again, you will not say no to us. Don't call me Oliver Twist, because I will always try to drag you out from wherever you are to come and baptize us with some knowledge. Thank you so much. We appreciate, and have a wonderful weekend.